In this video, we are going to look more closely into the free body diagram of an object on an inclined plane and how we could use the free body diagram to be able to solve Newton's second law of motion for objects on an inclined plane. So once again, when an object is on an inclined plane, the forces acting on it would be number one would be the force of gravity or the weight of the object that is equal to mg. And we have the normal force, which is parallel to the inclined plane. Perpendicular to the inclined plane. So normal force should always be perpendicular to the surface that the object is resting on. And if there's friction, then friction would be parallel to the surface. So in this case, it should be parallel to the inclined plane, and it should be opposite to the natural tendency of the object to move. So this object would naturally slide down, so therefore friction should be a force that is directed up the inclined plane. Now if you notice, there are two arrows here that are actually broken or that are represented with a dashed arrow. These arrows represents the components of the object's weight. So if you notice here, we have Wx, that means this is the x component of the object's weight, and we also have Wy, which is the y component of the object's weight. So in solving problems related to inclined planes, it is very important that we are going to tilt our axis like this so that the motion of the object will be along the x-axis. Then it would be easy to analyze the motion of the object. That is why this is considered as Wx, because this is along the x-axis, and this is Wy because this is along the y-axis. So the forces along the x-axis would be friction, and we have the x component of the object's weight, Wx, and the forces along the y-axis would be the normal force and the y component of the object's weight. So meaning to say, the weight of the object is actually a force that is somewhere between the x and the y-axis, and that is why it has its components. Take note of this, that if this is the angle given in the inclined plane, which is actually a very common scenario, the x component will always be mg sine theta, whereas the y component of the object's weight would be mg cosine theta, where m is mass, g is 9.8 meters per second squared, and theta is this angle right here. And in this case, our normal force is actually equal to the y component of the object's weight. So the normal force is mg cosine theta. Let me write that down. So now let us solve this problem. A 5 kilogram block slides down a frictionless inclined plane that makes an angle of 30 degrees with the horizontal. What is the acceleration of the block? So once again, we start with writing Newton's second law of motion. F net is equal to ma. And our net force here, our net force would just be the forces along the axis of the object's motion. So for example, the object here is actually moving along the x-axis, so we would only be looking into the forces on the x-axis. And in this case, we have Wx, which is the x component of the object's weight. So we will write that, Wx. And there are no other forces because the object is on a frictionless inclined plane, so this friction here will not be present. So in fact, our net force would just be the x component of the object's weight, and that is equal to ma. Now we expand. Since we are given the mass, then we could solve for the x component of the object's weight, which is mg sine theta. So we'll write that down. Wx is mg sine theta, and that is equal to ma. Now we substitute our values. So m is 5 kilograms multiplied by g, which is 9.8. Sine, the angle is given to be 30 degrees. So we will have sine 30 degrees is equal to, the mass once again is 5 kilograms multiplied by the acceleration, which is what we need to solve in this problem. You just need to plug these values in your calculator, and you can solve that acceleration is equal to 4.9 meters per second square. So once again, when an object is on an inclined plane and we are given the angle that the plane makes with the horizontal, the weight will have x and y component. The x component will be mg sine theta, and the y component will be mg cosine theta, and this y component would always be equal to the normal force, so therefore the normal force would also be mg cosine theta.